Okay, so let's code it out, the tabular method. So we will make this table. So firstly, let's make the entire table and let's have all the zeros in the table. So it will be like, let's call it DP array, and let's fill with zeros. How many columns we need and how many rows we need. So firstly, we will generate one single row. Okay, so how many elements should be there in row? It should be total number of columns, and column should be amount plus 1 because we are starting from 0. Please note that. That's why plus 1. So, and now what we have to do, we have to replicate this how many number of times? But this is the bad way of defining. Okay, I'll show you why it's bad way, but let me do that. And this, so this, what this will do, let's see that first, that what this will do. Okay, let's not put the braces right now. Let's print our DP array. And let's see what it's giving if we print. So our standard output, you can see 12 times because amount is 11 for this case, amount plus 1. Now we have to do this. How many rows are there? Rows are length of coins, which is M, plus 1, because even we are using one dummy coin, right? So oops, let's make it. And now let's print. Now you will see we just replicated. So we have total 4 rows now, 1, 2, 3, and 4. Perfect. But this is the bad way of defining. Why? Let's see, because what we want, let's see our table that we filled. The first row, not the starting from the first column, 0th row, I mean, let's call it 0th. 0th row starting from the first column should all be infinite. So let's put that. So rather than put infinite, we can put amount plus 1, like 12, because we are never going to reach 12 in our DP table. So we can do that. But let's put a really big number, or you can also put float in, that doesn't matter, like infinity, maximum value of float that we have in our Python. So we can do that, but doing this is a bad idea. Let's see that why it's a bad idea. Let me have the print statement because we need later. What we have to do, starting from in the 0th row, but starting from the first column, not the 0th column. What we need to put a really big number. Let's put 999 and let's print. Oops, what we got? This is an error. Why? Can only assign iterable. What does this mean? This means we can't just use one value, because from 1 to the entire last column, how many columns we have? 11. So we should also replicate this 11 times. So oops, just replicate this 11 times. It's like multiply this how many times? Amount times. And let's run. Now it should work. And you can see we just need infinity in the first row, but we are getting in all the rows. And that's the reason I said this is the bad way of defining. So what's the good way? Let's see that. So let's put it aside as a comment so that it's useful for future purpose. Good way is we need, until this we need it. So let's put it what we need. And for, I'm just using a placeholder, like we don't need, here you can put I, j, any variable, but we don't need it. Like we just have to run this loop. How many number of times? Amount plus 1, or sorry, coins plus 1. We need that much of rows. And now let's run it. Oops, what? There is something unmatched. It starts here. Okay, I forgot 1. Perfect. Now you will see the difference. So see, we just infinity in the first row, or I mean the 0th row, and we are getting it rather than all the infinities, even though it doesn't matter in this case. But you should know how it's working, right? When you assign something like this or that, you should know that which method leads to what. So this is a good practice for array slicing, you can say. You can put a really big number, or you can also put amount plus 1, because we are never going to reach that. So now let's remove the print. Now let's start filling our array. So we've already filled what we need, all with zeros, and first row with infinity except the first column, or the zeroth column, sorry, zeroth row with infinity except the zeroth column. Let's put it that way. So now we have to just loop. So let's loop. But since first, so I will be row, since first is already filled, we will start from, not from 0, but we will start our range from 1, and we will go until, how many rows we have? M plus 1. So we'll go until M. So it will go until M. Okay, so last is not counted. And similarly, we go for all the columns, and obviously first is filled. So first is already filled, right? Like this, that this is filled already with zeros, because we initialize our array with 0. So this is filled, and that's why we start from 1. And again, here we have to go for amount plus 1. So it will go until 12. So until 11 only. Amount is 12. So 12 is not counted. You know this. And now our choose and not choose case. So firstly, 0 case. Or what is that case? Where my coin denomination is greater than my amount. And in that case, what we were doing? Let's do that. Firstly, let's write that condition. What was that condition? That condition was when my coins, okay, so here it's a trick that my coins value for ith, we have to have I minus 1. Why? Because we have one dummy row and this dummy row and dummy column. So in order to access this, we should have I minus 1 rather than, because I is starting from 1. So if you put 1, then in order to get the 0th, this value, or I can explain better here, sorry, that in order to get this as 0th, because I started from 1, but we want 0th value, and that's why we want I minus 1. When any value of the coins denomination is greater than my amount, or you can write the other way around, and amount is j here, okay, in this iteration, then it's the 0th case. And for this purpose, we just directly copy from above. So if we want to fill the current ith j, we will just take the previous ith row. So previous row will be I minus 1 and same column, simple. Else, rest of the case we know how to fill. So dp array of I j is minimum of, in minimum what we take? Just above. So let's take first just above, which is same. Let me copy paste. This is just above. Minimum of just above, and 1 plus how many we have to go in, we have to stay in the same row. No, but we have to go left side. So same row, oops, but we have to go left side. How many times? Coin value, or the denomination of the coin. And we know how we can access the coins of I minus 1, right? So for the column, we have to go denomination times left side. Okay, this is the one case. And at the end, when this is done, we have to return the very last value, which is for rows. How many rows are there? M rows. And how many columns are there? Amount, which is last index, I mean mth index, and the amount will be the last, because let me explain, this will be 0, 1, 2, 3. So this will be third row and third column, 0 indexed. Okay, don't confuse that. But there is still one thing missing. Let's see that. Oh, I have written dp somewhere. I hope everywhere is dp array. Oh, here as well. Let's run. Okay, one thing, we are getting a wrong answer. Why? Because what if we are not able to, what if we are getting infinity here, right? Or 9999 in our case. What if we are getting infinity here? Then what you will do? You will return 99999. But when this is not possible, you can see here that when this is not the case, that we can't make the amount using that coins, we have to return -1. So we have to just write one condition, just after this looping that if my last column m and amount and last row, which is the last element, rightmost last element, is greater than, or I can say if we are getting it as 9, how many 9 were there? 7, I guess. Then simply return -1. And this is a bad idea to write 99999 like this. So instead of that, we can write something else. It's a DP array again. Forgetting it every time. Okay, so this is working. And if you run this, it should work. Perfect, it's working. But this is the bad idea. And we have seen that, and we know that it's intuitive that we will never reach amount plus 1. Okay, and so we can simply write instead of 99999, if my this value is greater than amount, then that's it, we are never going to reach even the amount. Okay, and if you run this also works. Okay, perfect. But we can still optimize. How? Let's see that. If you notice, let's come back here. For filling, firstly we filled this entire row, and now for filling the next row, we just need just above condition, and whatever it said, it's left. We just need 2 things. We don't need rest of the stuff, right? All this rest of the things are not needed, right? Only 2 things are required to fill. And so can't we use just 1D array of size amount plus 1, that is from 0 to 11, and every time update it, keep updating. So for writing the first, so for 0th is already written. Okay, for writing the first, we will make use of 0. Then for writing the second, we will make use of 1, and we will overwrite that array. And at the end, whatever we are left with, this last element will be our answer. That is what we need. So that's why you can see our space is not so good, and that's why we are a bit on the lower side. So let's optimize the space. So now optimize from, as I already discussed, time and space. Obviously, let me just recap it, that we are using a m cross n matrix, where m is the number of coins and n is, actually it's m plus 1 and n plus 1, but you know constant doesn't matter in BGO. So it's mn at the end, and space is also mn because we are storing all the elements in mn matrix. Okay, so this is really simple, but let's optimize. So optimize now. Optimize space to go off how much amount, which is n. Okay, where n is amount, mind it. So here, let me just copy this. We will need the same thing again, and we will just need a little bit of modification, which I'll do it quickly. That's why I'm taking it. Okay, I hope the indentation is correct, and let's comment this out. Okay, let's comment out later when we run it. So simply what we have to do, we have to just, we don't need now the 2D. So let's remove this. So this will be gone as well. We just simply need this much, even not the nested. We just need a single 1D array. So far so good. And also now we don't have to do 2 things. So just we have to fill. So zeros will be filled by default, and we just have to fill from the first column, right? 9999 or amount plus 1, which we are never going to reach. Okay, but just, so here we don't need the entire thing, right? We can just direct, sorry, here we will also need, sorry. Okay, so let's print that what we are getting until now, DP array, so that we are clear in our mind. Let's comment this for now, and also comment everything above, and let's run what we are getting as a DP array. See, 12 12 12 12 12, which we are never going to reach. 12 is like infinity for this case, you can consider like this. Now let's modify. As I said, time complexity will still be the same. Why? Because we need to iterate through all the coins, like we are doing one after the other. So time complexity will be still mn. Just space we can optimize. So here the same thing we will do. This will remain the same, but Now we just need the jth. Ith is not needed anymore because every time we are updating it. So I hope you will run it. If you try run this, you will get it. Okay. So, and also here, we just don't need this. So I is gone. Here as well, I is gone. It's like every time we are using the same previous row, previous array which is being there to update the new one, and that's it. I hope all the braces are correct. Yes, it seems like. And similarly here, we don't need the M. And similarly here, we don't need M. And our last should be this one and return -1. Things should work. Simple. But now you will see the difference in the space. Yeah, you can see memory is being improved. It's clapping. Perfect. So here time remains the same, just the space is optimized. Okay, so that's it about this. And please make sure to practice and stay tuned.